afternoon, ladies and gentlemen, and welcome to the ESA Pavilion for the press conference with our Director General. As we usually do know, unfortunately, the weather's not with us this morning, but it is now. So you will find English on Channel 4, and French is on Channel 5. If you are listening to this channel, you should be hearing English. On my right, we have Jean-Jacques Dordain, Director General of European Space Agency. On his right, Douglas, who is head of the Communication Department, and I'm Franco Bonacina. I will now immediately hand over to Jean-Jacques Dordain. Thank you. Thank you, Franco. Let me, for my part, wish you a very warm welcome to the ESA Pavilion. I'm not sure if you've had time to visit, but during my introductory speech, I'll give you a sort of virtual tour in any case. I was told the planes had stopped, but they appear not to be grounded. As you can see, our pavilion has two slogans, innovation and partnership. And this is what I will try to be demonstrating to you. It's also, I have to say, a very eventful period at the moment. And a very successful period, too. There are missions that were placed in orbit a few years back. Were very successful also in terms of launch of new recent missions, and also successful in terms of the decisions taken at the Ministerial Council last year. And I will try to cover these three different types of event and success. So, in a way, I will be following the order of exhibits in the pavilion, because at the left as you come in, you have knowledge, and of course, knowledge is the start of everything. From knowledge, we go on to services, citizen services, whereby all scientific progress can be translated into services for our citizens. And then here on my right, we have the competitiveness of the European industry and its innovative capabilities and its capacity to create jobs. That then is, roughly speaking, how I intend to signpost my presentation, a bit like our pavilion is. Starting with knowledge. As you've been able to see, if you've had a look around, we start with the universe, then go into the solar system, then onto Earth. As to say, we go from the greater to the smaller. So let me start with the universe. Regarding knowledge of the universe, there's an event which I think is exceptional, but which has been considered exceptional by a lot of the media because it hit the headlines of virtually all papers around the world. That is to say, the initial results of the Planck mission that you can see when you come in on your right. It's a fantastic picture because it shows you fossil light after the Big Bang. It's an absolutely outstanding image that was achieved thanks to the outstanding work performed by scientists who, using the raw data from 3 years ago, including all light between now and the Big Bang, have gradually eliminated everything that happened during that time period to leave us with just the image of fossil light. And that was an outstanding engineering feat because you have to realize that the color code on the picture is 1/1,000,000th of a degree. We're talking about absolutely fantastic accuracy. And this was possible thanks to the engineers that have expertise at very low temperatures because the Planck detectors were brought down to 0.1 degree. I don't think it's likely that going forward over the next few decades we'll do better than that. So this is the result of technological innovation that has been of vital importance in enabling scientists to take a step further towards understanding the origins of the universe and the Big Bang. But it's also an example of partnership, like all ESA's science programs, partnership between ESA, providing the launch vehicle, the spacecraft, and the member states that provide the instruments, plus France and Italy, because these are the two countries that provided the two main instruments on the Planck mission. So much for Planck, then. But next to the Planck imagery, you see a reference to the next launch of a science mission, which will be taking place at the end of this year. That will be Gaia, the Gaia spacecraft, which will be launched. This is a follow-on mission from Hipparcos, which was the surveyor of stars, if you like, 25 years ago. And Gaia is the new generation of this that will give us a very precise idea of about 1 billion stars. And in this case, innovation is, or will be, in orbit with the spacecraft, but also on the ground. Because I can tell you that one of the big challenges in Gaia was its ground segment and how we could digest such a vast mass of data that will be coming down from Gaia. So I just want to stress that innovation is not just about innovation in orbit. It's also innovation on the ground with respect to our ability to use ever bigger and more accurate and precise data. So, from the universe, let's move on to the solar system. There I've taken Mars as an example, because there are two major events about to happen. We've had one already, the 10th anniversary of Mars Express, 10 years in orbit around Mars. Time flies, of course. It's one of the first major milestones for me as Director General. It happened around Christmas. I remember when Mars Express went into orbit around Mars. And for the past 10 years, spacecraft has been regularly sending back data to scientific community, not just in Europe, but around the world. And I think that there too, I have to remember that the instruments are provided by member states, camera from Germany, mega instrument from France. They have all delivered and are continuing to deliver unique information about Mars. And this afternoon, my colleague, Mr. Jimenez, will be signing a contract with TAS, Thales Alenia Space in Italy, for the final development of the Exomars 2016 mission. This contract, as I say, will be signed this afternoon. And as you're well aware, 2016 mission is the first one of the Exomars program. And this will be followed 2 years later in 2018 by another mission, during which we will land a rover on the surface of Mars that is also stuffed full of innovation, in particular as far as instruments are concerned, and more specifically the drill down to 2 meters underneath the surface of Mars so that we can, if possible, detect the presence of any biological matter in the surface of Mars. So technological innovation, once again, whether we're talking about 2016 or 2018 mission. This latter mission, even though it's taken some time for reasons that you're well aware of, it remains unique. And when it's launched in 2018, it will be a major innovation compared with anything that's happened to date on the surface of Mars. Partnership, here involves partnership with Russia. I signed the agreement in March with Roscosmos for the 2 missions, 2016, 2018, and tomorrow. With Roscosmos, we will be signing the liability agreement. That's to say, who's responsible for what, not just in terms of 16, but also for the 2018 mission. Partnership encompasses NASA. They'll also be on board for Exomars in 2016 and 18. They have their telecom package on the 2016 orbiter and the MoMA instrument in 2018. NASA, therefore, is very much a stakeholder in Exomars, and of course the member states, first and foremost Italy, but also the UK and France, through their involvement in the MoMA instrument. That's what I would say about the solar system and Mars then. Now come down to Earth and its environment, Earth sciences. In particular, you know, we have 3 Earth Explorer missions in orbit now. They've been there for some years, Gautier, SMOS, and Cryosat. In that order, these missions are still up and running, including Gautier. And we know there are risks there because we have lowered its altitude quite significantly. But given that Gautier has already done much more than complete its nominal mission, we feel we can take such risks and therefore continue to bring down its orbit so as to improve our knowledge of the gravity field. Because, you know, Gautier has improved our knowledge of the gravity field 10 times, even 20 times. And by bringing it down, we hope to go even further. SMOS has also provided data on soil moisture and ocean salinity, and Cryosat too. Fortunately, I would say, is still giving us data. Unfortunately, the data themselves are not reassuring about ice masses at the poles, and North Pole in particular. This is accelerating, and Cryosat measures not only ice surface but also ice volumes. And the information we're getting back, unfortunately, indicate a speeding up of ice melt. Now, the topical event will be Swarm, 4 satellites to be launched at the end of the year. And this will give us information about the Earth's magnetic field and how it's developing, because you know the magnetic field, the Earth, is vital to us. So understanding that field is very important to understand our environment. It's vital to life on Earth. And the last piece of news I would mention is the 7th Earth Explorer, 7 already, that has now been selected by the scientists. It will be biomass that will provide us biosphere information, thus supplementing the information we have about the Earth and its environment. Now, each spacecraft, each Earth Explorer in itself, is a form of technological innovation. I won't go into the details, but there can be no scientific progress without technological innovation, and therefore we are bound to continue being innovative. Last thing I want to mention is the space station. You can see it over there behind you, but what we're showing is a turbine blade, a direct result of microgravity research on the space station. It's an aluminium titanium alloy produced thanks to our improved knowledge of alloys and how microgravity can be used in that sense. And the result is spectacular. As you can see there, a turbine blade in aluminium titanium alloy that largely outperforms all other blades that have been produced to date, including carbon ones. So my point is that the space station allows us to improve our knowledge to such an extent that technologies can be revolutionized, and from there we can go on to series production, as illustrated by the blade you see on display in our pavilion. Now, I can't mention the space station without talking about Luca Parmitano, who was launched on 20th of May from Baikonur to the ISS. So you know that Luca and his crew beat a speed record between takeoff and docking at the ISS. Luca is now on board the station. And on Saturday, he saw the ATV arrive, ATV-4. I'll come back to that later, but it doubtless brought him the tiramisu and the parmesan that he'd been longing for. As you are well aware, the partners have announced that Tim Peake has been picked to be on the space station as of 2015. So that was knowledge. Now services. As I was saying earlier, all scientific progress comes transformed into technological progress, and you see this with Copernicus. That's the start of our services. Obviously, this is a very major partnership that we have here with the European Union. Services already up and running, in particular. A little further on, you have the Charter on Natural Disasters. ESA and CNES were the two founding members of that Charter on Natural Disasters, but it's now become an international charter that virtually all the space organization operators in the world have signed up to. And as unfortunately there seem to be more and more natural disasters, when that happens, all the signatories to the Charter make it possible to provide the data and information so as to best possible manage the situation and the post-disaster situation. Now, I can't mention Copernicus GMES without mentioning ProbaV, launched on the 7th of May on the second Vega launcher, its most recent satellite. You see the mechanical and thermal mock-up in the pavilion. You can see it's a small satellite, but while small, it's extremely effective and efficient, and complex too, because it combines major technological innovation and an operational instrument for vegetation. The first images of which you can see, and maybe it's no coincidence that the first ProbaV image is the south of Brittany with the Nantes area and its estuary, but unfortunately the French Prime Minister, didn't come and have a look in our pavilion this morning. But if you like, you can see this first imagery provided by the vegetation instruments alongside the ProbaV mock-up. Now, regarding GMES and its services, innovation is more on the side of services than technologies. We are making both efforts and progress in order to improve the operational nature of our satellites, and this is something that you should bear in mind when you visit the pavilion. The second service on display is, of course, a weather service, meteorology. That, again, is a major partnership success with the EUMETSAT. The economic spin-off of this partnership was presented by EUMETSAT after the start of METOP second generation. Unfortunately, despite the financial efforts by member states, that decision was taken 3 years after Meteosat third generation, which means we have to develop the new generation, not just of the geostationary orbit meteorological satellites, but also the new generation of polar orbit meteorological services, which in terms of workload and industrial effort is enormous, but it shows the economic value of weather forecasting. You know that we launched 2 MET satellites last year. This year, we will be implementing the decisions taken by the Ministerial Council in 2012 regarding METOP. Second generation phase A and B1 are now completed. That was in May. 2 parallel studies, 2 industrial studies in parallel, which means that we can have competition. The phase A B1 has been extended by a few months so as to take on board the needs or the need to ensure that we can have a controlled fallback at the end of life for these satellites, which are in polar orbit. As you know, as far as possible, we try from the design stage to make sure that we can have controlled re-entry of such spacecraft, which is why we extended the phase AB1 by a few months. And the phase B2CD ITT will be issued in September of this year. Now moving on to EGNOS Galileo. There too we have a major partnership with the European Commission, or the European Union more generally, but the Commission specifically. In this pavilion you have on display EGNOS. 2 years ago, in fact, in this same place, I signed the initial agreements involving some airports, because the first 3 that took EGNOS services were French airports. And here, in this very place, I signed the agreements. EGNOS is now fully up and running. Galileo now has 4 satellites in orbit. We have done the first positioning exercise with 4 satellites. Of course, not 4 satellites. We don't always have 4 satellites always visible, but our demonstration has shown that the Galileo signal is easily the equal of the best systems around the world. And we're not the ones saying it. It's the organizations using Galileo services that have told us that this is a very good signal, because with 4 satellites we're already giving accuracy equivalent to that of the best operational services. We are continuing to deploy the constellation, and the FOC will complete at the end of the year, and the first Galileo services will be available as of October of next year, 2014. So we have technical innovation with the atomic clock, the signal generator, but also innovation in terms of services. And this is the legacy, the heritage of EGNOS, which will ensure that Galileo will meet the ambitions of the European Union. Moving on to the third and last area, competitiveness. I'll start with telecommunications. It's the largest commercial space sector, 50% of European industry. Telecoms are therefore, by definition, the vital industrial sector in space. And of course, what's new here is the launch of AlphaSat. By the entrance to the pavilion, you have a full-scale model. It's the largest satellite of its type, 7 tons. There are various partnerships involved. ESA CNES to start with, because it began with agreement between ESA and CNES, with CNES as the initiator along with French industry, the project. That was via the AlphaBus platform. So it's an ESA-CNES partnership, Astrium Thales partnership as well, and an ESA Inmarsat partnership as well. So that using the AlphaBus platform, we could run the first AlphaSat mission. It's a public-private partnership that we're very proud of because it's a huge partnership, 450 million invested by Inmarsat, and it really is a genuine PPP because we are not giving Inmarsat a market to just technologies. It's member states that are taking risks on new technological development. Inmarsat is taking the risk of using this new technology to open a new market. So they're the ones holding the risk. It is therefore a virtuous partnership in which each one takes a share of risk. The spacecraft, I think, is due to leave Toulouse for Kourou today to be launched on 25th of July. So it's a major milestone for ESA, its member states, and European industry. I also wanted to mention that on board AlphaSat, there's the laser terminal provided by DLR in Germany. And this laser terminal is an absolutely vital component in the data relay system that we are currently developing. I was mentioning operational services like Copernicus just now. Now, the Copernicus operational services will be very much facilitated in terms of access to data. When we have the data relay system, it will be much quicker, and that uses this unique laser terminal. So if it works, if it's successful, I think it will be possible to impose that as a world standard for high data rate communications. This is why AlphaSat is not just important in terms of qualifying AlphaBus and important for Inmarsat and its operational services, but it's important for us in terms of qualifying new technologies that will subsequently be used in data relay systems. And I want to mention also that on Sentinel-1, there'll be a laser terminal that will enable us to use the data relay system. So much then for the generation whose development is now ending with AlphaSat. But we're already looking forward to the next generation with the development of Neosat and Electra, which were decided last year's ministerial. Time is pressing because the space-borne telecommunications market is moving forward at pace with the advent of new technologies and new forms of propulsion, electrical propulsion. So we cannot wait. We have to move fast, whether it be Neosat or Electra. On the 9th of January at IPC, we asked member states authorization to place industrial contracts, and along with industry, we will be hurrying to develop those spacecraft. It's a partnership with industry, but also, of course, with SOS Global, the operator, as far as Electra is concerned. From telecommunications, I'll go to the second area of commercial interest, launches. In terms of news, well, I do have to remind you that the second launch of Vega took place on the 7th of May, which for me, personally, was an event I would call historic, because it was the first time in Europe that we had the first two launches of a new launcher go successfully. It never happened before. So that's historic in itself. So first two launches successful, problem-free. And yet the second Vega mission was very complicated, firstly because of the new flight program being qualified on the launcher. That's never easy. So a new flight program of 5 reignitions of the upper stage, 3 satellites placed in orbit, and 1 controlled re-entry of an upper stage, because we try not to leave debris in orbit. All of this went perfectly smoothly and successfully. Put Probe V into orbit, satellite I was just talking about, but also the first VNREDSat satellite, commercial satellites, Subway Ariane Espace, and also with Latvia. First satellite. I'm proud. Oh, sorry, Estonia. I'm proud that we enabled Estonia to become a spacefaring nation. So that was 7th of May. On the 5th of June, 55th successive and successful Ariane 5 launcher. And I never tire of saying this, even if it's 55 in a row. I'm always on edge because it's a complex launcher. But what was new was the HSS-3 lateral separation system for the fairing, which dampens the separation shocks. So SSS-3 worked very well this time. The time before was on Herschel Planck. And, well, Herschel and Planck got into orbit, but SS3 itself didn't work that well. This time it did, which meant that we were able to significantly dampen fairing separation shocks. So good news for the future. There was also a new onboard computer on Ariane 5 there. So the launcher worked very well for its 55th successful launch in a row. Also, in June, we'll be going to the IPC, Industrial Procurement Committee, next week in order to get member states' approval of the Ariane 5 ME contract, the industrial contract that will enable us to cover industrial work through to the ministerial in 2014. So there is no delay expected. Ariane 5 contract part on Ariane 6. Configuration will be selected on the 30th of June. I said they could wait till the 14th of July. I was told it would be done on the 3rd of June, so fine. But you know, in France, the 14th of July is a special date. So I said, if they need an extra fortnight, they can use it to choose the Ariane 6 configuration, after which we will start the industrial process, a competitive process, aimed at seeing how we could reduce launcher production costs for a launcher in Europe, because here, innovation will be manufacturing a launcher in Europe. I'm not targeting here technical innovation, but a type of innovation that will guarantee that production costs for a launcher in Europe will be as low as possible. Now, obviously, launchers are also partnership programs because whether we're talking about Vega or Ariane, we work using integrated teams, ESA, the CNES, and the Italian Space Agency for Vega, and on Ariane, it's also an integrated team, ESA, CNES, but also with some DLR engineers, and soon, I hope, also from the Italian Space Agency. Then the space station, the ISS, not from the utilization, but the development side. Monday afternoon on the 15th, the ATV-4 Albert Einstein docked with the ISS, and that was the first time that, at least on the Russian side, there was contactless capture. As usual, we were waiting to have contact in the cone, and this time it was the other way around. We had capture before contact, and there were Russian colleagues in the control room in Toulouse, CNES facilities, and my Russian colleague said, well, I've seen 325 Russian docking maneuvers, and this is the first time that this happened. So I congratulated them on the record set by Soyuz, 6 hours, and he congratulated me on the docking accuracy of ATV-4. So it was an outstandingly successful maneuver and operation. Over in the corner, you will see the connection between ATV and the Orion service module, because you can see that it's a direct legacy from the ATV service model to Orion. As you probably know, 2 years ago we stopped ATV production, not because we were fed up with producing them, but because we preferred to continue developing new technologies, and the agreement with NASA was that the service module of the Orion capsule will be provided. I thought and said after the ministerial that this was a historic step forward, because it's the first time that NASA has placed ESA on the critical path in terms of crew transport, and I think that should be remembered. The MPCV work is moving forward. In the January IPC, we took the steps to cover industrial work through to the summer, as requested from industry. We got a ceiling price from them at the end of May. And this means that we will be able to go to next week's Industrial Policy Committee to make a proposal to cover industrial work through to the ministerial next year. So contractually speaking, we're on track, on time. In agreement with NASA, we have postponed the PDR till October, November, because just like NASA, we have some issues with mass that we are in the process of solving, but we have put back the preliminary design review without delaying the development itself. The launch is still scheduled for 2017, and you will be able to see the MPCV service module mock-up over in the corner on my right. And last but not least, in terms of competitiveness, technology. I've already mentioned Proba V, technological jewel, but just over it, you'll see Proba 3. Last year's Ministerial Council enabled us to take a major step forward towards Proba 3 development. Proba 3 is demonstration of formation flying. And now we have the necessary means. We've asked industry to make their proposals to bid for the industrial contract, so we can say that that project is well on track. And the last thing that you can see is on your left when you look at Proba V and Proba 3, as to say the Incubator Centers. And I'm very proud of those, I have to say. We have developed and are increasingly developing business incubator centers, which have been hugely successful. Well, the business incubation centers are about developing partnerships between ESA and those who want to use ESA technology, either to develop applications or services. And this is a partnership project. That is to say, we put in a little bit of money, a lot of technical expertise, and then we turn to partners who are willing to invest with us in new applications and services. We have now 6 that have been set up. The first one was in Bavaria. And in April of this year, I went to Oberpfaffenhofen myself to celebrate with the Bavarian Minister of the Economy of the 1,000th job created there in just over 3 years. Very high-level jobs developed through this business incubation center. And I stress that they are partnership-based. We have partnership between ESA, the national agencies, and in Bavaria, it's DLR, of course, the regional administration that invests, but also banks. And as I said, when a banker puts money in our business, then that's a good sign, because they don't have the reputation of being very risk-friendly. So that was the Bavaria Center, and is it Thursday, isn't it, Franco? This week we'll be signing here the agreement to set up the 7th business incubator, which will be in southern France. in the Toulouse-Aquitaine region. These business incubators are growing in power, and in a way it is a response to what I was asked to do by the ministers at last year's Ministerial Council, that is to say, develop competitiveness and growth. That is what we're trying to do every day.
For 20 good minutes for questions and answers. Raise your hands, show your hands to my colleagues, Paul, to start with, or Brigitte, starting with Brigitte here. Introduce yourself, please.
Merci, Richard Ingham, journaliste de l'Agence France Presse.
Thank you. From the Agence France Presse. Somebody from Israel granted us an interview just a couple of weeks ago, and he talked about the development of the satellite market, saying that we're focusing more on electrical propulsion satellites, which would mean that the fairing of Ariane 5 would need to be changed. And what he said is that there should be an Ariane 5 ECA adaptation. Are you in favor thereof or not? Yes, so much so that this is a suggestion that will come at the next PB launch this week or next week. I can't remember when that is, but I think that this suggestion has arrived, and indeed that's a suggestion that will be put to the member states either this week or next week at the next meeting of the launchers program board. And so it's an adaptation, which is a very limited adaptation. Based on that, we will be increasing the volume under the fairing, and it's a suggestion that is now going to the member states. And as soon as we get some feedback, positive feedback, and financial support from the member states, then we shall be starting that development. That should be done very quickly. Arianespace defines the needs, and we have to find solutions to meet those needs and requirements. And this is what we're going to be doing in the next few days. The idea there again is to have this operational change at the latest by 2015.
Microphone, please.
Merci beaucoup. Oui, une deuxième question, si vous permettez.
I had a second question, if I may. Where are you going to find that money? Will there be extra budget lines, or I don't quite know. You need to ask the member states. I mean, the member states concerned, you should ask. You can interview these member states. It's France, first of all, so you can ask my colleague, Jean-Yves Le Gall. Then there's Switzerland, because whenever we talk about fairing, Switzerland is involved, of course. And then there might be funding from other member states, but I mean, first and foremost, it's France and Switzerland. Now, there again, we're not talking about huge amounts of money, nothing extravagant. I mean, it's tens of millions, just a few tens of millions of euros, no more, maximum. How much does that mean? 30? You said a few million euros. How many is that? I don't know. I didn't make the suggestion myself, but I believe it's going to be 30-odd million. I suppose. I don't know. But I mean, given the scale, in the scale, it's not 100 million, it's not 100 billion, it's a lot less than that. Yes, I got that. Thank you. Now, and to be quick, you mustn't spend too much money, right? And for the MPCV, you're going quite quickly, but you're spending a little more money, because I didn't quite understand how you can actually ask the IPC to validate an industrial suggestion if you still have a mass problem. Because settling that mass problem, doesn't that mean that you will have to change the industrial offer? No, because I think we have the right methodology to reduce mass and those mass issues. And you can ask my colleagues from NASA, but I mean, these problems are mass problems for the MPCV, general mass problems. I mean, it's not the service module itself that is the bottleneck of mass problems or challenges. This is something we need to do with NASA. I mean, we can't do it on our own. And we have room for hope. We can be confident, and I met with Mr. Bayer in Baikonur, and indeed we believe we can solve those mass problems. Now, should we wait for all mass problems to be settled before moving on to industrial contracts? I think things would go much more slowly than they do. And what is the ceiling price that you will be offering at IPC? The industrial price, I don't quite know. What I know is that I have 450 million euros, full stop. And the ceiling price, that's for development. For the development, not for the rest. I mean, I'm not talking about the part that is subscribed in 2014. What I'm interested in is the NASA supply. And we ask the industry to commit themselves to a price to provide the service module to NASA. Much more important, I would say, than the ceiling until 2014, because if I'm given a ceiling in 2014, and then if people tell me in 2014, people tell me, well, for 2015, 2017, it's going to be 3 times as expensive, then I'm not going to be amused. And that's not what I want. I want to know the ceiling price until 2017. Jonathan.
Could we have a word about Herschel? The transponder on Herschel was switched off 2 or 3 hours ago, bringing an end to that mission.
Oui, si j'ai bien compris.
Yes, if I got that right, I think Herschel was turned off at 2:45 p.m. Now, that being said, it's not a surprise. It didn't come as a surprise because it was expected, programmed, and Herschel doesn't have any cryogenic liquid on board, and so it's getting warmer, and as it is heating, it becomes unusable. So we switched off the Herschel transponder. Yes, right. C'était à 14.
45, because I gave him the wrong information. It's
Je pense
14:25.
que
25. 25 ou 45? 25, 14h25. Anyway, it's there's a 20-minute difference.
Just raise your hands and yes, Theo.
Théo. For the Soyuz and Rocket launches, what can you tell us by the end of the year? How many Soyuz launches by the end of the year, and Rocket? Are you relying on Rocket for next year? Well, I'm not the operator. According to the operator, there will be 4 Soyuz launches this year, and so we are working on that basis, and that's it, really. Rocket, now, according to the latest news I got, they have a government launch coming up in the summer, and we are next. We're next. So again, we were told by the end of the year. But what else can I tell you? Not much. I mean, I don't control things at Arianespace, and even less at Rocket. So I'm a customer more than anything else, client. D'autres questions? Merci de bien vouloir vous présenter.
De Futura Science. Le bras robotique ERA, vous comptez le lancer avant la fin de l'année ou au tout début 2015 2014
je sais pas. Là aussi, ça dépend des Russes, mais ça dépend pas de nous. Nous, ça fait bien longtemps, malheureusement, que nous sommes prêts à le lancer. Je sais pas, Thomas, c'est quand le lancement? Là, je suis navré, mais je préfère demander à mon collègue.
We still have no official information other than end of the year.
End of this year?
Yes.
Okay.
We heard there are some technical investigations ongoing. So far, the launch date is not changed from our Russian side, end of the year.
Bon, donc voilà.
Right, but there again, it all depends on the Russians, to be honest. One last question, maybe who would like to take the risk of asking the last question? I'm not hitting anyone. I've never.
Mariette Leroux, I'm also provide us some more detail on the agreement that's going to be signed with Russia on the Exomars.
The agreement I talked about concerning the matrix for liabilities, is that what you're talking about? It's the liability matrix. Okay. That's a document that is a highly technical document. So in March, we signed an agreement in which we defined what each party would bring to those Exomars missions. And tomorrow, we will be focusing on the details, because it's not just what each party is actually providing, but under whose responsibility. And so it's a responsibility matrix, and it's a much more precise, detailed document based on which we can then manage those missions together. And Mr. Popovsky had highlighted that when we signed the agreement, really. For the first time, we will have to manage something jointly, so it's an integrated project team that we need. And what each of the parties actually provides will need to be merged. And so we need an integrated management of the program and of the 2018 mission in particular. And to do that, we needed to know who was in charge of what.
Et bon, voilà, dernière question. Richard.
Maybe? Richard. Mr. Dordain, Mr. Israel, during this interview, also talked about another project. He said he wanted to speed up launches in Kourou, now taking place on a 3-week interval, and that should be cut to 2 weeks, 2-week interval. Is that feasible? I can't answer that question. It's an extremely challenging question. It's very complicated, very complex. There are so many stakeholders. I mean, you have the launchers, you have the satellite preparation, you have the tracking stations, you have the reconfiguration of the tracking stations based on the type of trajectory that we have for a launch, etc. So, I mean, I can't tell you, I'm afraid. And I always said that 3 operating launchers, we didn't quite know what it meant. It's probably much more complicated than having the same launcher used 3 times. So indeed, we have to work flat out together, including involving all partners, those doing launchers, those preparing the satellites, those who have the on-ground facilities, those who manage the ground facilities, etc. So it's a joint work between the ESA, Arianespace, the industry, the CNES, the French CNES. I believe it's an interesting challenge, but unfortunately, launches are not equally distributed in a given year. And so if we were to have 10 launches each year, and if those were to be more regular every 5 weeks, say, then we would live in an ideal world. Unfortunately, it's not quite the case. As you came to realize this year, for quite some time we could not organize any launch because the vehicle was not ready, because the satellites were not ready. And then suddenly, towards the end of the year, there were many launches coming up. And so we should try and cut the window or the period of time between 2 launches. That would be very useful, but it's a big challenge. Le Figaro. Yes, recently there was a debate on solid propulsion for the first 2 stages of Ariane 6, and then that was challenged by different members of the Académie de l'Air et de l'Espace. I was wondering whether it wasn't a pity to actually stop focusing on the cryogenic approach or solution. Well, first of all, there's the official answer. I'm a civil servant, and so I do what ministers ask me to do. They took decisions in 2012, and I listen to ministers more than I obey ministers more than academicians. That's the first thing. Then if ministers decide otherwise, then I'll do whatever the ministers ask me to do. So my mandate, or the mandate I was given in November 2012 was quite clear, and I try to apply it. I apply it rigorously, even, I would say. And that's the first part of the answer. The second part of the answer would be, well, I wouldn't want people to think that this choice that was made in November 2012 was the result of thinking for just a few months. I mean, we've been working on the configuration of new launchers for years, 10 years. The FLPP program, I think, was first voted, I can't even remember, I mean, long time ago. And it means that for at least 10 years, we've been working on the configuration of new launchers, and we've been spending money jointly with industry to do things. And some of those academicians were involved and worked in industry back then, and so they should know the studies that were carried out concerning the FLPP program. Yeah, so yes, you can always say you have better ideas, but I mean, at a given point in time, you have to decide, you have to make a launcher, so you can work for 100 years on launcher configurations, and then you will always have come up with better ideas, better solutions. But I'm asked to make a launcher. I'm not asked to develop a new approach and new configurations, etc. So I just apply the decisions that were taken, full stop. But there again, I insist, those decisions were not taken whimsically on a whim, but rather it was the result of 10 years thinking. It's the FLPP result, and I think we are at FLPP 3. There was first type. There's a whole history really. Right, that's it. Thank you very much. There's much more waiting for you at the ESA pavilion. That's 4:45. You are welcome. We'll be signing the Exomars contract tomorrow at 2:30. Just a highlight. Tomorrow at 2:30, AlphaSat. And on Wednesday at 11:30, from 11:30 to 12:30, there will be a press event on Earth Explorers. So you're always more than welcome at the ESA pavilion to visit it and to listen to our press conferences. Thank you very much for your involvement. Thank you.